Hello girls, I hope you're having a great day and staying safe at home. So if you remember in the last upload, I talked about the general trends in the modern periodic table and we discussed about the groups, okay? And please remember children that hydrogen has been placed on top of group 1 above the alkali metals, though hydrogen is a non-metal. Why? Because the electronic configuration of hydrogen is similar to that of alkali metals. Why? Because both hydrogen and alkali metals have one valence electrons. That means they have one electrons in their outermost orbit. But hydrogen is very small in size and many of its properties are completely different from those of alkali metals. So when we discuss about the alkali metals of group 1, hydrogen is ignored because alkali metals, but hydrogen is a non-metal, and when we look at the size, hydrogen is a very small in size, the atom of hydrogen, whereas alkali metals, they are bigger as if you compare it with hydrogen. But in some periodic tables, hydrogen is not placed in any groups. Okay, it is treated as a very special element and it is placed alone at the head of the period, that is at the top of the periodic table. Now moving on to the periods, number of shells. On moving from left to right in a given period, the number of shells remain the same. Supposing we are talking about period 2. That means all the elements that belong to period 2 will have only 2 orbits. All. As you go across, they will have only, if it is period 3, then they will have only 3. All the elements that belong to period 3 will have only 3 shells. So from moving from left to right in a given period, number of shells remains the same. Okay, so example, we take the third period, the number of shells remains 3 equal to the number of periods. So let's take a quick look. Elements of the third period, we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. So if you see the atomic number 11, 12, 13, so when we arrange it, how many shells are we getting? We are getting 3 shells. Okay. Now, if you notice here in the electronic configuration, the number of electrons is increasing one by one. Here 1, then 2, then 3, then 4, then 5, 6, 7 and 8. So in a given period, number of electrons in valence shells increases from left to right by 1. It successively increases. Now, valency of elements with respect to hydrogen increases from 1 to 4 and back to 1. Now here, why 1 to 4? That is, sodium can give away 1. So valency 1, give away 2. Valency 2, give away 3. Valency 3. Now 4, we do not consider. Now 5 can receive 3. Valency 3. Can receive 2. Valency 2. Can receive 1. Valency 1. So it increases and then again it decreases. We are talking about the valency. Okay, but the valency with respect to oxygen increases from 1 to 7. Okay, that I already explained to you. Now moving on to the size of the atoms. Size of the atom decreases while moving from left to right in a period, because as we move from left to right, the number of protons increases. The nuclear pull, which decreases the size. That means the positive, as we move, one electron is being added and the positive charge inside the nucleus is also increasing. So if the nuclear charge is increasing, what will happen? The electrons which is in the orbit will be pulled closer towards the nucleus. So as a result, you will see that the size of the atom decreases as you move from left to right. Okay, so in a particular period, alkali atoms have the largest size and halogen atoms are the smallest. So lithium is the alkali metal and The halogen, that is fluorine here, is the smallest if you compare. Now moving on to the properties of elements. Properties of elements depend upon the number of electrons in its outermost orbit. In a period, the number of electrons in valence shell changes. Properties of the elements in a period differ. Okay, they are different. Now reactivity first decreases up to group 14 and then it increases. So in group 1, elements are the most reactive. Okay, elements in group 1, the most reactive elements you'll find in group 1, while group 17 are the most reactive non-metals. Group 1, metals, very reactive, and group 17, most reactive non-metals. Now, when we look at the metallic character in any given period, you will see that when you move from left to right in any period, any given period, the metallic character gradually decreases. It becomes less and less. Because if you look across any period, you will see that in the beginning you will see metals and then metalloids in the middle, and finally it will turn into non-metals. Why? Because it changes from metallic to non-metallic. And remember, the last element of each period is always an inert gas. Now if we take the example of the second period, you will see lithium and beryllium are metals, boron is a metalloid, and carbon, nitrogen, oxygen, fluorine are non-metals, and neon, you know, is an inert gas. Now talking about the oxides of elements of any period, you will see that they become less basic and they will change into an acidic character, because in the beginning you have alkali metals which are basic, and as you go on, if you look at the third period, okay, now, or the second period here, carbon is there. So you'll have carbon dioxide, which is acidic, nitrogen dioxide, which is acidic. So if we take the example of the third period again here, when we come here, oxides of the third period, you will see, okay, sodium oxide, magnesium oxide, aluminum oxide, then silicon oxide, then phosphorus pentoxide, sulfur trioxide will all change into acid when you put it in water. Okay, sodium oxide is basic, and then you have dichlorohepta oxide, which is also acidic in nature. Next, we move on to the study of specific groups. So you all know group 1 are the alkali metals and elements like lithium, sodium, potassium, rubidium, cesium, francium, all have one electron in their outermost orbit. Here you can see one electron. Okay, and they have valency 1. So they are placed in the first group, that is group 1, the first column on the left of the periodic table, and they are known as alkali metals. Why? Because they react with water to form hydroxides, which are very strong alkalis. Okay, that is the metal. If you take any alkali metal, lithium, sodium, potassium, okay, and it reacts with water, alkali will be formed, the metallic alkali, lithium hydroxide or sodium hydroxide or potassium hydroxide, and hydrogen will be released. Okay, now next, when we move to the characteristics of the alkali metals, you will see that the electronic configuration, as you go down the group, the number of shells will increase. Okay, and the last orbit will have one electron. And where do you find them? Since they are very, very reactive, you will not find them in the free state. They are always found in the combined state. And what type of nature? They are very soft metals and can be cut with a knife. So they have low melting and boiling point. Okay, and what type of bonding do you see? All alkali metals, salts, except some salts of lithium, this is the exception, they are ionic in nature. That means they show electrovalent bonding. They can easily give away this one electron in its outermost orbit. Okay, and then when they give away, What type of bond do they form? They form an electrovalent or ionic bond. Okay, when they come in contact with air, action of air. Now in air, what do they react with? They react with oxygen and water vapor in the air. Okay, so you will see sodium reacts with oxygen first to give sodium oxide. That sodium oxide will react with water vapor which is present in the air to get sodium hydroxide. Now that sodium hydroxide will further react with carbon dioxide which is present in the air to form sodium carbonate and water. So due to reactive nature, elements of group 1 are kept in inert solvent like kerosene. Remember, they easily react with oxygen, so you cannot keep them open in the air, so they must always be stored in kerosene. Now reactivity of these metals increases down as you go down the group. It becomes more and more reactive because what happens is the number of shells become more. Okay, that means the attraction between the protons in the shells and the electrons goes further and further away. Outermost orbit goes very far away, so they can easily lose the electron which is in the outermost orbit. So if they can easily lose the electron which is in the outermost orbit, means it becomes more and more reactive. Okay, now how do they react with water? They react violently with water and produce hydrogen. Any metal, sodium plus water, you'll get sodium hydroxide and hydrogen. Potassium and water, you'll get potassium hydroxide and hydrogen. If you remember, we had discussed this in the hydrogen chapter. Okay, next is action of acids. They react again violently with dilute hydrochloric acid and dilute sulfuric acid to produce hydrogen, forming the respective salt. If it is hydrochloric acid, then the metallic chloride will be formed. If it is sulfuric acid, then the metallic sulfate will be formed together with the evolution of hydrogen, which is given out as an effervescence, and it burns with a pop sound, if you remember. And they form unipositive ions very easily, so they are very strong reducing agent. That is, they have only one electron in the outermost orbit and they can easily give away that one electron and they will become positively charged. Okay, so when freshly cut, that is, they are so soft, they are stored under the kerosene. You take it out from the kerosene and you can cut it with a knife. Okay, so when you cut it, you'll see silvery white metallic luster. Metals shine, the luster, but soon they become dull because they come in contact with air, oxygen. They tarnish, means they form the oxide. Okay, and all alkali metal salts give a certain color to the flame. These colors are very important, children. Lithium, crimson red; sodium, golden yellow; potassium, lilac. Okay, alkali metals. How do you get alkali metals? By electrolysis of their molten salts. So children, this is all for today. In the next upload, we are going to discuss about group 2, that is alkaline earth metals, and the remaining groups. So till then, stay safe. God bless you.